Had video issues today. So this is number 21 from the review. Part A, we got G and H. Rewrite G as a single logarithm without negative exponents. Okay, and their final answer should be natural log of one thing, basically, or some expression. I hope you remember that you can take those coefficients and move them up top. So natural log of x cubed minus natural log of x to the 1/2. And then we can condense that down to x cubed over x to the 1/2. And in calculus, that would be a fine answer. But in pre-cal, you need to reduce that. So 3 minus 1/2 would be 2 1/2 or 5/2. That's a property of logs there. Alright, H. This looks more like a trig thing going on. Rewrite H as an expression in which cosine x appears once and no other trig functions are used. Okay. Sine squared in 1, that's a pretty good hint that something's going on with sine squared plus cosine squared is 1. So sine squared minus 1 would be negative cosine squared over cosine, so that would just be negative cosine of x. So yes, cosine of x appears once, no other trig functions are involved. That would be a flashback question. So maybe. But there's only one flashback question over the
see that in our future?
previous 6 months of our time together. So any one thing has a low probability of being it, and yet it will be something. Part B. The functions j and k are given by this stuff. Solve j of x equals 0. Between 0 and pi. Okay, so another weird interval here. 2 sine x cosine x minus cosine of x equals 0. Let's factor out a cosine of x. Cosine of x, 2 sine x minus 1. So cosine of x equals 0. Sine of x equal 1/2. But I'm only allowed to look in the first quadrant. Let's see, cosine is 0 at the top and bottom, but I can't get to 3 pi over 2, so just pi over 2. And I need to be careful. I've included the endpoint in that interval, so I can include pi over 2. So if that had been a parentheses, then we wouldn't be able to include pi over 2. Sine of x equals 1/2 at pi over 6. And 5 pi over 6, but I'm not allowed to use 5 pi over 6. So just those two answers. So be careful, pay attention to the intervals. Part 2, solve k of x equals 3e. So 8e to the 3x minus e equals 3e. There's a variety of ways to go about this one. What do you think we should do first? I think step 1 should be the same for everybody. Thoughts? E's are what's throwing people off. But let's add e to both sides. And then, what do you want to do next?
Make them both 2.
What's that?
E squared and then make them both 2.
2 cubed and
Yeah.
2 squared?
Mm-hmm.
It's not wrong, but those e's in there aren't helping anything. I'm going to go 2e to the 3x equals e. Divide both sides by 4. And then I guess I could, here's where the paths diverge. What do you do to get a variable out of the exponent? What could I do to both sides that would allow me to get this thing out of the exponent? Like a natural log. Although be careful, that 3x isn't on the 2. So let's hold off on this. So natural log of e is 1. On this side, I'd have to split that up. Natural log of 2 plus natural log of e to the 3x. So natural log of 2 plus 3x equals 1. All right, almost there. X equals 1 minus natural log of 2 over 3. I've worked that problem 3 times, and each time I worked it a different way each time, so I don't know. This is well, it's still got the same issue, so I don't know. 2e to the 3x equals e. So one student wanted to get the 2 on the other side so they wouldn't run into that problem we just had. So you could do that. That sort of switches the problem to the other side. Then he said, let's divide by e. I said, that's fine, but you have to know what e to the 3x over e is. What's e to the 3x divided by e? Oh, let's work an easier problem. What's x to the 7th over x squared? X to the 5th. Because what did you do? 7 minus 2 is 5. 3x minus 1 is just 3x minus 1. And then you can natural log both sides. So you'd have 3x minus 1 equals natural log of 1/2. And I guess that doesn't look like this, but it's that negative coefficient can become an exponent, which flips it over to 1/2. That's a crazy problem with a variety of ways to get there. Part C. We haven't done one like this today, so I definitely wanted to do this. Find all input values. Okay, fancy talk for x's. In the domain of M that yield an output value, a y value, of 9/2. So cosine of 2x plus 4 equals 9/2. And there was no interval given. In fact, it says all. So I'll need to be careful about that. Cosine of 2x equals 1/2. Let's see. Cosine is equal to 1/2 at 2 pi over, no, at pi over 3 and at, it doesn't matter. You can say negative pi over 3, or you can go the long way around and say 5 pi over 3. Either one. But that means 2x needs to be those things. And if I want to get them all, then I need to rotate around 2 pi to land back where I started. rotate around. K meaning as many times as I want. One rotation as many times as I want. But that's not it, because now I need to divide by 2. So pi over 6 plus pi k, 5 pi over 6 plus pi k. There is not one of those on the review, so I'm glad we got to that. One of those meaning where there's a 2x as an argument, and so you have to be careful about coming up with more answers and dividing by 2, that sort of thing. So there aren't those on the review worksheet, but there are plenty of those on worksheet 5 if you want to see more of those.